Hello guys, this video will just be a quick introduction to the idea of complex and imaginary numbers, as well as some of the language used when talking about them. First off though, what are the real numbers? Well, the real numbers are the numbers that you'll be familiar with. These are numbers such as 1, 2, minus a half, minus 4, pi, and so on, and they all fit nicely on this number line here. Now these real numbers are all well and good up until we try and solve an equation such as x squared plus 4 equal to 0, because, as you can see, we end up getting to x is equal to plus or minus the square root of minus 4, which has no real solutions. So what can we do? Well, back in the 16th century, mathematicians defined a new number I that has the property that when squared is equal to minus 1. Therefore, I is equal to the square root of minus 1, and they called this number the imaginary unit. Using this new number I, we can solve our equation, getting x is equal to plus or minus 2i. Also using I, we can extend our number system to include a whole new set of numbers, the imaginary numbers. These numbers are all multiples of I, and include numbers such as I, 2i, minus 2.5i, pi I, and so on. Now, what if we wanted to add a real and an imaginary number, such as 2 add 5i? Well, this cannot be simplified. In fact, this is a complex number as it has both a real and an imaginary part. This notation here is important, but it just means that the real part of z is 2 and that the imaginary part is 5. Do notice that we say the imaginary part as a real number, which might be quite confusing. In general though, any number of the form x at yi, where x and y are real, is called a complex number. Going back to our graph from before, this is actually called the Argument diagram. On the horizontal axis are all of the real numbers, and on the vertical axis are all of the imaginary numbers. Using the Argument diagram, we can plot any complex number, and in future videos you'll see how useful this diagram is when solving certain geometry problems. So to plot a complex number such as 2 add 5i, I'll just move 2 to the right and then 5 upwards, as so. And to plot a complex number like minus 1 minus 3i, I'll just move 1 to the left and 3 downwards. And that will be it for this brief introduction to complex numbers. I really hope you enjoyed the video. If you did, please do check out my other videos on complex numbers. I'm going to cover the entire syllabus for AS and A-level further maths. Bye!